Welcome to today's webinar, Mobile App Testing with AWS Device Farm. Our presenter today is Trent Peterson. Trent is the product manager for AWS Device Farm. He joined AWS through the acquisition of AppThwack, an app testing company that he co-founded. Prior to AppThwack, he was at Intel designing system automation solutions trusted to test products used by millions of customers with an emphasis on simplicity and user experience. Today with us, we also have Nikhil Dubadi, Andrew Hawker, and Pavel Voinarich. They will be our webinar moderators who will be engaging with you and answering your questions throughout the presentation while Trent presents. Trent, welcome. The floor is now yours.
Great. Thanks a lot. And thanks again, everyone, for joining us this morning. So to get started, I want to tell you a little bit about a problem that you're likely familiar with, and that is the problem with quality, the struggles that developers have with building quality into their mobile applications. And the first way that this exhibits itself and why we should all care about it is because as users of apps, we have a voice, and that voice goes through reviews in the app markets. And so we're all familiar with one-star reviews and the effects that they can have on our app rankings and discoverability. And with the millions of applications in the various app markets that are available, consumers they have a lot of choice, so they don't have to stick around with your app and put up with poor quality. And so from a consumer standpoint, there are lots of choices, and the first application that works the way that we expect it to work, that's the app we're likely to stick with. If it misbehaves, then we're likely to uninstall it and go looking for another application. Now, from a developer standpoint, building quality it's easy to talk about, but it's not so easy in practice. And the reason why it's not so easy in practice is because it's an extremely complex and complicated environment that we must develop for. So in the wild, not only are we dealing with myriad form factors, tablets, phones, different resolutions, we also have different operating system versions, carrier modifications to firmware, manufacturer modifications to firmware, different radio stacks, and then environmental factors. So, is this single strength good? Is it poor? It could change throughout the session as the user walks through a building or leaves their office. But from a user standpoint, they don't care about all of that, and we're all users too. We don't care about all of that complexity. All we know is that we want our applications to behave the way we expect them to, regardless of where we happen to be. We want that seamless experience. But from the developer standpoint, it's extremely complicated, and that's something that we have to deal with. And you're likely very familiar with the device cabinet or the device drawer or the device desk or the device lab concept, where lots of phones and tablets and various devices sit around. Some are more sophisticated than others, but it's expensive, it's cumbersome, and it distracts from the true purpose of your business, which is to build great apps that your customers are going to enjoy. Nobody wants to be messing with USB cables and devices and USB chargers and trying to figure out how to run automation on them. So after talking to many developers, we decided that this was a problem that we could tackle from an AWS side. And that's why we built AWS Device Farm, which enables you to test your applications on real Android and iOS phones and tablets in the cloud. So in today's presentation, I'm going to give an overview of what Device Farm is and a brief history of it. Then we're going to jump into a demo because I think it's much better to show you how the service can help you versus just talking to it. I'll give a demonstration on continuous integration with Jenkins. So how do you take the testing that I'll show you through our AWS console, how do you take that and scale it so that it's integrated in with your development process through the Jenkins plugin. And then finally, we'll wrap up with Q&A. So AWS Device Farm supports the testing of native, hybrid, and web applications on Android and iOS devices. And those devices scale. So we like to talk about scale here at AWS. The AWS Device Farm scales in a couple of different ways, and I'm going to talk to those. So first, we have hundreds of unique devices for you to choose from. And so when I say hundreds of unique devices, I'm saying that there is a list of devices of makes, models, operating systems that you can choose from. Behind each of those devices that you can select from, we actually have many instances in AWS data centers that will be allocated to to you when you request them, so that we can make sure that the device is available when you need it. AWS Device Farm was designed with security in mind from the ground up, and this involves both hardware and software isolation. So on the hardware side, the devices themselves are actually shielded from one another in a way that they can't take video or photos of another device running another test or another customer's application. They're also shielded so that they can't talk to each other or see each other over a wireless connection. And then they're also, each device has its own Wi-Fi connection. They're not on shared internet connections. There's no local area network. There's no way for a device to talk to another device or another piece of infrastructure in the system. So you can rest assured that your tests as they're running on the device, you have a one-way connection out to the internet from that device, but there's no way to talk into it. There's no way to talk to other devices and so on. This also expands over to the software side. So when a device is running your tests, many of the frameworks we support actually run tests both on the device itself and the machine that hosts it. So if you're running these tests locally, you're probably familiar with running your tests on your laptop or on a server, and you have a device tethered to it over USB. In Device Farm, we have a similar construct, although the host machine is actually brought up on the fly, runs your tests, and then is destroyed at the end of your testing. So you're not sharing an execution environment with other customers or even yourself and your history. And that goes beyond just the security story, but it also ensures that your tests are running in a known environment every single time, so you can reduce the amount of noise that can be introduced from a dirty environment. Flexibility is built into the system as well. So you can test both manually and automated. And so from the automated standpoint, we support many frameworks such as Appium, Calabash, XeTest, and so on. And we'll talk a bit to that, and I'll show you in the demonstration the types of test frameworks that you can choose from. In addition to running those automated tests where you can run many tests across many devices in parallel at a time and get results back in minutes, you can also choose a device to interact with in a remote access session. And this is actually a feature that we launched earlier this year in beta and just released as generally available last week. And this allows you to interact with a device through your browser as if it was on your desk. So you can rotate the device, install applications, swipe and gesture, and so on. And again, I'll get to that in the demonstration so you can see what I'm talking about. Now, what do you get once you've executed? So what is the value here? So we produce reports so that you can solve any issues or identify problems that may arise during your test execution, whether that's automated or through a remote access manual session. You'll see high-level results. You'll see video recordings of the session or the test execution. You'll see screenshots, and those are based on when you want to take those screenshots, so it's totally up to you when to capture the snippets or the images of your application. You can also download logs and performance data. And then the console interface that I'm going to show you, everything in it is actually built on top of our public APIs. And those APIs are available through our SDKs, our CLI, and through plugins, which is right now Jenkins, which I'm going to demo, as well as a plugin for Android Studio, so you can seamlessly incorporate testing on real devices in the cloud into your development process. So pricing. Device Farm starts, you have a couple options. This goes back to that flexibility point. You can choose to have unlimited testing, which starts at $250 per month. That's based on device slots. A device slot is, for instance, you're essentially buying concurrency. So if you buy an Android device slot, you can test as much as you want on any of our Android devices. You can just test on only one at a time. If you bought 2 slots, you could execute on 2 at a time. If you bought iOS slots and Android slots, then you could test on both platforms at the same time. You can choose any devices to test on. They'll just simply be executed with a concurrency limited by the number of slots you have on your account. The other option is to pay as you go, and you simply pay 17 cents per device minute. Regardless of the method that you choose to use, you can switch back and forth. And there's no setup fee, there's no requirement, there's no contract requirements, and so on. So you can move up and down through your levels depending on your testing needs any given month. And you can get started with 250 minutes for free. So after the session today, I encourage you to go and give Device Farm a try, and you can do so with those 250 minutes. A quick history. So Device Farm launched in July of 2015. In the intro, it was mentioned that I came in through the acquisition of AppWhack, which was a service in the same space. So we've actually have technology and a team that has been in the space for quite a few years now. And it is available in the Oregon region, US West, although it's available globally, and we have customers all over the world running tests on these devices. It's also important to note that even though the devices are in this region, we have a device selection that is global. So we have India market devices, Chinese market devices, North American market devices, and so on. They simply don't have the carrier connections from those regions. But the devices themselves, it's the actual hardware that you would find in those other markets. And you can find Device Farm in the console under the mobile services section. And when I do the demo, I'll probably skip over that, but I encourage you to find it on the right side. If you just search for Device Farm, you'll see it there. And a quick note before we jump into the demo about what you can do with Device Farm, or what we see developers using Device Farm for. So we see developers testing iterative changes. So this is implementing a new feature, kicking off a quick regression test before committing or just after committing to a local branch, just to make sure that nothing is breaking before they push it back to mainline or out for review. We also see testing cumulative builds, and this goes into that continuous integration or Jenkins story that we'll talk about a little bit later. So using Device Farm on commit or for nightlies or for milestone builds and so on. We also see testing to verify functionality just prior to release. So I will talk to this in the demo, but if you don't have automation, it doesn't mean you can't use Device Farm's automated testing functionality. We provide a couple frameworks that require no scripting at all. So we have a built-in Explorer and a built-in Fuzz Test that will do a basic compatibility test on your application automatically. So you can choose from those just before release, and we see developers using this as well, just to make sure that they're not going to have any problems when they go out to the market. And then we see developers monitoring their release applications, so running tests on a regular basis against production environments, using Device Farm as a canary. So if there's a problem that exhibits on Device Farm, or a device can't reach a server or backend infrastructure, they'll set off an alarm and perform the investigation necessary. And finally, using the manual remote access capabilities of Device Farm, we see customer support teams using Device Farm to reproduce end-user problems, whether that's a customer coming through a support channel or through a crash report through an automated analytics platform, reproducing those issues on the same device in a simulated environment, and walking through those problems. And then once they're done, taking that report and pushing that out to the developers so that they can actually fix and further debug the problem. And with that, we'll jump over to a demo of Device Farm. So when you first visit the Device Farm console, you'll be greeted by a first run page that will prompt you to create a project. And I'm in an account that has many projects already, but I'll walk you through creating that project. So a project in Device Farm it's simply a way for you to organize your tests, your remote access sessions, your uploaded files, and your results. So you can mix and match iOS and Android tests and sessions within a single project. We see developers using projects to differentiate between different types of build, different titles. It's completely up to you how you want to use the project construct. And once we've created a project, we simply go to the project, and from the project we can create an automated test or remote access session. So we'll first start out with creating one of these remote access sessions. So we click Start a New Session, and now we're enabled to choose a device to test on, and you can see that we have both Apple iOS devices as well as many Android devices to choose from. I'll go ahead and choose an iPhone 5C for this test. Confirm and start the session. And then now on the back end, we're going to go and look for that device, a device that's available. And you can see that it's found one and now it's preparing that device for my session. And while that's preparing that device, we'll hop back over to another tab. And here's our session that we're waiting for. We're waiting for it to start. While that's going, I'm going to go ahead and create an automated test session as well. So similarly, we create a new run. We select either web or native. For today's demo, I'll select a native application. We can then upload an application. Now, a quick note about the application that I'm going to upload is that this is a binary that is no different than a binary that you would push to your beta testers or even push to the market. There's no SDK or things that you have to modify. There's no instrumentation in your application. You simply take your app as is and provide it to us. The only caveat is that if it's an iOS application, it just needs to be built for a real device and not a simulator. And we have instructions on how to do that in our documentation that we'll link to at the end of the session. Once your application is uploaded, we provide some metadata about it so you can verify that this is in fact the application you'd like to test. The next step is to configure the type of test. And I mentioned before that we support many different frameworks. So this list has now been filtered down to just show you the Android frameworks that we support. We have the built-in tests that I mentioned that require no scripting. So the Explorer, which will walk through your application, sort of you can think of it as a crawler or a very naive user. It's not going to test your business logic, but it does know how to interact with controls. So if it finds a button, it will touch it. If it has a menu, it will know to click on those items and walk through your application. We also have a fuzz test here, which is a form of monkey testing that will just hit your application with random input, and you have control over how many commands you're going to send and so on. For today's demo, however, I actually have tests that I've written in the instrumentation framework. So we'll go ahead and upload those. And just like the Android application I uploaded in step 1, there's no instrumentation, nothing I had to do special, proprietary to my tests to make them work. These are the same tests that you would run locally on your own local devices or against the emulator. So there's no instrumentation necessary here either. Once we've uploaded our tests and our application, we're ready to select the devices. So by default, it's selected a curated pool called top devices that contains devices that we've identified as popular and spanning a good coverage of devices that are out there in the wild. However, you can choose from any of the devices we have, and as I mentioned before, we have hundreds of different devices to choose from. We have a concept called a device pool, and a device pool is a set of one or more devices that you can reuse from test execution to test execution. So you don't have to select your devices one by one every single time you come into the service. You have two different ways to create a device pool. One is to simply click on the devices that you'd like to include and include them explicitly. The other way to build a device pool is to do it based on rules. So for instance, we can create a device pool that is only composed of tablets and only by a specific manufacturer. And we can see that it's selected all of the Samsung tablets as specified by the rules I've defined. And the power here is that we're constantly adding more devices to the fleet for you to choose from. And this allows you to create a device pool that will adapt as we add devices over time. So you don't have to come in and edit the pool and add new Samsung tablets in this example every single time a new Samsung tablet comes out. For the sake of the demo, I'm going to go ahead and just use this top device pool. The final step here is to specify the device's state. And so this allows us to control the environment that our tests are going to execute in. So from this step, we can add extra data. And what this means is we can upload an archive with arbitrary data inside. So maybe your application or tests assume that there should be media images, videos, or a test database or a configuration file, it's completely up to you. You simply upload a zip file. We will unzip it to external memory on Android and to your application sandbox on iOS, and then you can make use of it from your tests and from your application. You can also install other applications. So you can use this functionality to test dependencies, interoperability between your application and other applications, or even testing an upgrade flow from a previous version of your app. And you can upload one or more applications and specify the order in which they'll be installed, and that will happen before your tests, or before your application under test that we uploaded in step 1 is installed. Next, you can set the radio states. This allows you to, for instance, turn Wi-Fi off before your application is launched for the first time. Next, you can specify the device's location. So even though the location of the devices is physically in the US West region, you can specify a latitude and longitude, and we will override the location on the device so that your application and the device itself will think that it's somewhere else in the world. So you can test things like geofencing and other location-based functionality within your app. Finally, you can specify the device's locale. So this is helpful for testing localization, where you can specify the language and dialect for the device. Okay, and so finally, we take a quick look at our run that we've created, and everything looks good. So we'll go ahead and create it. And so now we can see that we have the run in the scheduling state. And Device Farm takes an opportunistic approach. So we have 5 devices we've selected for our test run. As soon as any one of those 5 devices becomes available, test execution will start running. And we can go ahead and click on this, and we can see that of the 5 devices, 2 have already started. And a common question we get is, how soon do your tests actually run? How do you know, what is your wait time going to be? As you can see, for most devices, it's seconds, it's minutes, if not seconds. And there's no need to wait for all devices to finish running tests before you can look at results. As soon as any one of these devices finishes execution and the results are pulled in, you'll actually see them appear here. So you can start doing test analysis and problem analysis as tests are executing. With 5 devices, it might not be as impressive, but if you're doing 100 devices, for instance, or even more, you might actually start to see that there's an issue in your tests or with your app and want to stop execution completely so you can go and fix the issue and run another test. So you're not going to incur the charges associated with running on all 150 devices, if you catch an issue early on. Okay. So while that's executing, let's take a look at an automated test report. So I have a number of test runs that I've run previously. So this is the same application and same test that we just uploaded. This is what will happen once it's done. So on a high level, you can see how many tests passed, how many tests failed, and so on. Just below that, we pull out unique failures. And unique failures is a way of us grouping issues based on the error message. And the idea here is that if you run lots and lots of tests, you might have lots of failures. Rather than having to parse through each one of those failures to figure out if it's something that's important or something to look at, we do that pattern grouping automatically. So in this case, we've had 4 failures, however, only 2 of them were unique. And this one, the first one, actually occurred 3 times. And the idea here is that you can fix it once and likely address it in all 3 cases. From here, we can actually click on a problem and go straight to that particular test that failed. So right now, if you look at the breadcrumbs here, we're on a Samsung Galaxy Tab 4. We're inside of a test suite called Fixtures Test. And the specific test that we're in is this test NFC is on. So down below, we can see that we have logs that we can filter and manipulate from the console. And again, I just want to remind you that everything you see here in the console is available through our API. So you can programmatically grab all of this, pull it down, archive it locally, use local tools, and so on. We can also view screenshots, and we can see here that NFC showed up as false in our little status menu within our application, so we can get a visual on the failure. We have performance data. Now, this performance data doesn't look particularly interesting because the test only ran for a fraction of a second, so the number of samples we have to look at here, not very interesting. However, as we back our way up, I will show you how the report is organized in such a way that as you back up and you have more samples, you'll actually see this performance data become a little more interesting. And finally, we have a Files tab. And on the Files tab, you can download, for instance, the instrumentation output, the logcat, and on iOS, you'd see the device log. And we can also download video of our tests. So you can see here that there was a quick video showing our test execution. So jumping back over to the summary, below unique problems, we have a list of all devices that we tested on. So under the devices that we've tested on, we can see that a couple of them actually passed, all 56 tests passed. So let's jump in and take a look at one of those. So again, the tabs are very familiar to what we just looked at a test level, although we're at the device level now. We see details, we see screenshots, performance data, and so on. So on the screenshots view, we can actually see screenshots for every single test that was run on this device. We can also download all of the files that were generated for the device, and so on. And finally, on the highest level view, we can actually view screenshots across every device. So this can give you a way of quickly analyzing screenshots and screens of your application, catching UI issues that may exist. Okay, so let's take a look back here at our session. So that was an automated test schedule and an automated test report. Now let's take a look at that session that we scheduled at the beginning of the demo for remote access. So right now we're looking at an iPhone 5C. And you can see that we can actually navigate and gesture on the screen and so on. We can also upload applications. And again, just like the automated session, there is no need to do any special instrumentation or manipulate your application in any way. You simply provide your iOS application, in this case an IPA file. You don't need to whitelist UDIDs or anything of that nature. We'll take care of everything for you. And once that application is uploaded, processed, and installed on the device, it will be available for your session. And you can upload more than one application onto the device during your session. You can also, let's see, and we can change the aspect of the device. In this case, I'm on the portrait mode on the home screen on iOS, which does not support landscape mode. So we can see that it failed to actually set the mode for us. If we're in an application that does support landscape, then we can create or change that landscape, change that orientation on the fly. Once we're done with our session, we simply stop the session. And once it's done being processed, you'll have access to logs and video of your entire session. So you can go back and use that either for your own records or maybe attach it to a ticket that's being passed on to developers. One other thing that I wanted to show you is that when we were looking at that project that had lots of run executions results, you can actually see a list of previous applications that we've tested, as well as the test results. And so you can actually identify trends here. In this case, we can see that we have a pretty steady ratio of pass to fail. All of this data, again, is available programmatically, and we've actually seen customers build dashboards on top of this to identify, for instance, a particular test, if it fails more than one run in a row or more than 5 runs in a row, whatever their threshold happens to be, then alarming on that. As you may be aware, test automation is not necessarily a 100% thing, and it can fail for any number of reasons, whether it's a problem with the automated script. These are also real devices, and they have, they can be finicky. So we see customers that have taken the approach of actually using a heat map type of approach to identifying problems. and building dashboards on top of this data. Okay, and with that, I will switch back real quick to the presentation. So a little bit about continuous integration. So what we just looked at was I was obviously manually clicking around in the console, scheduling tests. But now let's say you're ready to do this programmatically or from within your development environment. So today, Device Farm, we have official plugins for the Jenkins continuous integration platform. We also have a plugin for Gradle, which also allows you to run tests from within Android Studio. So through these means, you can kick off tests automatically while you're developing in Android Studio, as well as automatically, on build or on demand through Jenkins. In addition to those official plugins, we also have an AWS CLI that includes Device Farm's API. So from that CLI, you can upload applications, schedule tests, and so on. So you can use that CLI, you can script around that CLI, and integrate Device Farm into your process. Finally, the Device Farm API is available through the AWS SDKs, and those SDKs cover languages from Python to Ruby to .NET and so on. So regardless of the tool or your language of choice, there's likely an SDK for you so that you can build an integration on top of Device Farm and incorporate us into your process. Okay, so we're going to hop back over to the demo. Okay, so what we're looking at here is a Jenkins dashboard on my machine. You're probably familiar with this interface if you've used Jenkins. So I have a couple projects here. So I'll go ahead and jump into my Android app. And within my Android app, I can configure the Device Farm plugin. And the Device Farm plugin is available through Jenkins. So if you go to Manage Plugins and you look for AWS-Device Farm, you will actually find the plugin and be able to install it with a single click. Then you can add it as a post-build action in a project, and you can configure things like which Device Farm project it should bucket into, which device pool you would like to run on. You can specify what the application is that you're going to test, so where Jenkins will look for your application. You can also specify things like storing results locally. What this means is that after test execution through Jenkins, it will automatically pull down your artifacts, so things like screenshots, videos, and so on. It will pull them down to your Jenkins environment. You can select which kind of tests to run. So just like in the UI when I showed you, like we selected instrumentation tests, you can select instrumentation, for instance, specify the test package, and so on. And once you've done that, then you can go to your project. And from in your project, for instance, I can say build now, and we can see that we now have a build scheduled. If we go to our project, as soon as Jenkins is done uploading the application, we'll actually see that build show up here. And so we can just see that our run just showed up here. And it came from Jenkins, and it's now executing tests on Device Farm programmatically through that plugin in Jenkins. Now, I manually selected to build now. Of course, you can have Jenkins configured to kick off builds when a file appears in a folder, for instance. So you don't have to actually go into Jenkins and click build now every single time. And once your tests are completed, you'll see those build results show up within your Jenkins interface. And so we can see here I've run a couple builds already through the plugin, through this project. We can see pass-fail results just like we could in the console. We also have a link to the full report, which brings you to the Device Farm dashboard and the report interface for analyzing results. We can also see overall pass-fail trends from build to build to build, so you can identify identify that there are issues or not issues. from build to build. I mentioned before we've seen customers build dashboards, so this is following a similar idea. And you can also see which build artifacts it actually relate easily your results in device farm to the particular build and tests that were used to generate it. All programmatically, all part of a continuous integration story. Okay. And with that, I will flip back to the presentation. Okay, so we've talked, I'll do a quick recap here. So I've shown you quite a few things. So Device Farm allows you to run tests in an automated fashion and a manual fashion. So you can take automated scripts that you've built, run them as is on your application as is on many devices at the exact same time, and get those results back in minutes, those results being videos, screenshots, performance data, and so on. We also support many frameworks like I showed you. So regardless of the framework that you choose, or we've seen some teams that actually select multiple frameworks, you can be sure that you have a single point to run those tests in a scalable fashion. Then you can run tests manually in a remote access session, reproducing customer issues, debugging during development, and so on the device through your browser. Then you can take those your automated tests and your usage of Device Farm and completely incorporate it into your continuous integration story using our plugins or doing it yourself through our SDKs and API. Now, I invite you again to try the service out. It has a free trial so that you can kick the tires a bit. We also have resources available to you. Those include our forum, where we have a community that helps each other out. We answer questions there. The team here answers questions there. We also have Device Farm samples. So the application and tests that I ran in today's webinar, those are both actually available to you on GitHub, and you can analyze the code. It follows best practices that we've seen for building scalable, robust automation that will run across many devices of various with various operating systems and various performance characteristics. We also have an email address that you can contact us at if you want to reach out. But for now, I invite you to actually participate in the Q&A session, which we will spend the next few minutes doing. And again, if we don't get to your question, feel free to reach out to us through the email address you see. And also make sure that you fill out the survey on the left-hand side, as that helps us make sure that the content in these webinars is living up to your expectations and making sure that you're getting the information that you need. Thank you very much.
Great. Thanks a lot, Trent, for a great presentation. And right now we'll move into Q&A. Please take a minute to reply to the polls on the left-hand side before we get started with the live Q&A. So it looks like we have about 20 minutes left for Q&A. And please continue submitting your questions. I apologize in advance if we do not address all of them that have been submitted, but our moderators will continue to answer them, as well as Trent answering some of them verbally. So I'm going to go ahead and hand it back over to Trent.
Okay, great. Okay, so there's a question here. Okay, so the first question, is a device deleted after or before a test, and how do we prevent others from accessing an app? So the device itself is a real physical piece of hardware. We do not use emulators or simulators in Device Farm. So when you're running on actual hardware. So when we say that it's a Samsung Galaxy S6, it is literally a Samsung Galaxy S6 running your application and running your tests. We do reuse that hardware between customers. However, before and after and during your tests, We are looking at that device, we're analyzing that device, and after your tests are done, we do a number of cleanup steps. So the question about, how do we make sure that nobody else tests on your app? So after test execution is completed, you'll actually see a test that shows up in the results that actually is called a teardown test. And one of those steps of that test is to remove your application. If for any reason that fails, we're unable to uninstall your application, or the device bricks or otherwise crashes during execution, we will put that device into a quarantine state. And what that means is that a technician will actually analyze that device, figure out what went wrong. If we can't fix the issue or we can't solve the issue, the device will actually be destroyed if the device is compromised in any way. So this serves a couple purposes. One is that this cleanup that we do, so not just uninstalling the application, but doing a number of other steps, clearing contacts and so on. The goal here is one, protecting your IP and protecting the security of our developers using the service, but also to make sure that your tests are executing in a clean state. And I mentioned this earlier in the presentation, that it's very important to limit the number of potential problems. You don't want to go into a test report and see a bunch of failures, and it's because the environment wasn't clean. And also I mentioned before that where your tests are executed, so the machine that's actually connected to the device, that is virtual, and that machine is torn down and destroyed between uses. So the devices are reused, the machine executing your code is not, and that's how we ensure that your application and your test code are secure between customer sessions. The next question is, how fast do devices tend to do startup and cleanup? And there's a comment here about that on simulator, that this is especially a problem. So because these are real devices, we don't have the same performance issues that emulators and simulators might have. However, we do a number of steps during the setup and teardown that I mentioned. We do not charge for all of that time. And so when you look at a report, you'll actually see that there's a column that shows you how much time your overall test execution took for the entire run. As you drill into that run and you look at a suite, you look at a test, you'll see that same number. It will be scoped to the particular level in the hierarchy that you're at. When you look at that number, if you hover over it, it will show you how much was billed and how much was actually taken. And on a run level, those numbers the number you're billed for is always going to be less than the overall execution time. And this is because we don't bill for what we consider our overhead, which are things like cleaning up the device or preparing the device before execution. We don't start billing until your application starts to install and once we've verified that it's uninstalled. Okay, the next question is, can you test upgrading versions of apps, for instance, installing a version and then downloading a new version from the App Store? So today, through our remote access capabilities through the manual session, you can install an update. So you can install a previous build of your application and install another build and test an upgrade flow. Through the automated capabilities, you can simulate this using fixtures. And so what you do is, in step one of when you're scheduling a automated test run, you upload your application, the newest build. This is your build under test. In that last step that I showed you, where you can upload other applications and set the location and so on, in that step you can upload an older build of your application. And what will happen during execution is your old build will be installed first, and then your new build will be installed over the top of it. What we do not support is, for instance, if you want to install a previous build of your application, configure it, run tests and so on, and then install a new build over the top of it, that's not something that we support today. However, you can simulate that through the remote access capabilities. So what you would do there is you would start a session, you would upload the old build of your application, interact with it, then upload the new version of your application, and then interact with that. The next question is, are all devices located in the same area? And can we choose to run tests in specific regions? So today, Device Farm is in the US West 2 region, as I mentioned before. And although they're all in that region, they are available globally. But the devices you can choose from are not region specific. So even though they're in US West 2, they're not just North American devices or just US devices. We have devices from all over the world available for you to choose from. And we, like I said, we do not have devices in other regions today. There's a question is Device Farm for Android only, or does it do iOS as well? So it does do iOS and Android both. So you can choose from Android and iOS devices, both for automated. In today's demo, I showed you how to do an Android test. The iOS flow is nearly identical. You upload an IPA file, you select the test framework you'd like to test on, you select which devices you'd like to test on, you configure the environment, and then you run your tests. And Device Farm will find the devices you've chosen and execute your tests in a parallel fashion. And that's true for both Android and iOS. The test results are also identical. So you will get screenshots, you will get video, you'll get performance data, logs, and high-level test results in the same way, regardless of Android or iOS. So if you're, and as you likely are, developing applications for multiple platforms, Device Farm offers you sort of a one-stop shop for testing all of your titles, regardless of platform, on these real devices and getting reports back in a consistent fashion. And then in remote access, so for manually interacting with devices, we also support both Android and iOS. So in today's demo, I demonstrated manipulating an iOS device through my browser. Android works in a very similar fashion. You can select an Android device, install applications, gesture and swipe and so on through it. There's another question here is, does it cover HTML5 apps or native apps? So it supports, in today's demo, I use native applications. So I uploaded an APK for Android and an IPA for iOS. However, you can test HTML applications or web-based applications in Chrome on Android and Safari on iOS if you're using automation. So when I scheduled my automated test run, you may have seen that there was a web icon there at the very beginning when it asked us what kind of application we want to test. If you select web, we support Appium, Java, JUnit, and Appium Java TestNG, and Appium Python. And with any of those three frameworks, you can test web applications in the Chrome browser and Safari browser on Android and iOS respectively. On remote access, you could install any browser of your choosing and interact with your web app through that browser in a manual fashion. So again, Device Farm supports you whether you're using a native application like I did in today's demo, a web application running in a browser. It also supports hybrid applications. So if you're using you're developing an application using a framework like Cordova or Xamarin and so on, we do support testing those applications in Device Farm as well. So the type of application is not so important for us. We support them all. There's a question here, is there any option to run tests on unmetered devices without having to run setup and teardown? For example, a one-time setup and run continuously on the app. So the short answer is no. The longer answer is that the setup and teardown are automatically generated and run on your application or on your tests. Now that setup and teardown, they execute at the very beginning and the very end. So if you upload a test package that has 100 tests, we do not run setup and teardown individually for each of those tests. We will run setup at the beginning, run your 100 tests, and then run our teardown to uninstall the application, wipe the data, and reset the device. There's a question here about what is the pricing for Device Farm. So you can find information out about Device Farm's pricing if you go to our aws.amazon.com/devicefarm. You can find information about our pricing. It will also be in the deck that will be sent out after today's session, or in the video that's sent out after today's session. And the pricing, again, we have a couple options for you. One is the monthly subscription, which starts at $250 per device slot. That's unlimited testing, limited in concurrency, so how many devices can test at the same time, based on the number of slots you've purchased. Or you can choose to pay as you go. So if you run a test that takes 5 minutes, you run it on 5 devices, you would be charged for 25 device minutes. And I should note that regardless of the method you choose, you can actually purchase slots, and again, your execution is going to be limited by concurrency. If you suddenly have a need to run on 100 devices at the same time, when you're scheduling a run, you can actually choose to use the use the metered pricing, even though you have slots. So you could do a burst and run on 150 devices at the same time, paying the 17 cents per minute charge, even though you do have device slots available to you. Another question about pricing is, do we need to buy 2 separate device slots if you have an iOS and Android, or could you use both of those, test both with a single device slot? So device slots are differentiated in 2 ways, one on the platform and one on the type of testing you're going to be doing. So we have 4 types of device slots today. We have automated device slots for Android and for iOS. And we have remote access or manual sessions available for Android and iOS. So for instance, if you want to test on both iOS and Android devices as part of continuous integration using automation, you would potentially buy at least 1 slot for automated Android, 1 slot for iOS automated, and you'd be able to run tests on both. If you also wanted to interact with devices remotely through your browser, then you would also need to purchase slots of those relevant types. You can do this in 2 ways. One is when you're in the console through the UI, you'll see a link to purchase packages. These are pre-configured or pre-packaged slots for common usage scenarios. So for instance, a continuous integration package that includes 2 Android and 2 iOS automated slots for 4 slots total. You can also manage them yourself going to, there's an account settings page within the console, and you can purchase slots, downgrade slots, and so on. And it's extremely easy to use. I should mention that slots they have a 30-day minimum. So when you purchase or they have a monthly billing period minimum. So whenever you purchase a slot, it's going to be billed prorated for the current billing month. You can choose to automatically remove it at the end of that current month, in which case you won't be charged for the subsequent month. There's a question here whether or not you can run your own test cases. So as I showed in the demo, you can upload your own tests written in any number of frameworks that we support. So again, that's things like Appium, Calabash, UI Automation, UI Automator, XCTest, and so on. Regardless of the framework that you choose, you write your tests. You've likely written these tests already. You're running those tests locally. You take those same tests and you can upload them to Device Farm, select the devices you want to run on, and we'll take care of executing them on the devices you've chosen. So yes, absolutely, you can run your own tests, and that's the developers that we see having the most success with the service are writing their own tests. They're choosing when to take screenshots. They're choosing which business logic within their app to test, and so on. There's a question here about whether or not we support Appium with Node.js today. So today we support Appium, Java JUnit, Java TestNG, and Python. We don't support Node.js Appium tests today. However, our roadmap is guided by your input. So for instance, Python was implemented earlier this year because we had a lot of information on our forums, and we talked to a lot of customers that were telling us that it was important. So if Node.js is important from an Appium standpoint, I encourage you to let us know on our forums so we can potentially add support for it. There's the question here about whether or not we can run tests in commercial automation frameworks, for instance, Ranorex, We do not currently support running tests in Ranorex specifically. However, similar to my answer on the last question, feedback like this is great because it can help guide our roadmap and which frameworks we support next. Today, the focus has been on the official frameworks offered by Google and Apple, as well as popular open source automation frameworks like Appium and Calabash. However, the addition of additional frameworks is not limited to just the open source solutions that are out there. There's a question about, is there a timeout for too long or frozen tests? So if your test hangs and so on. And the answer is yes, there is. It is 60 minutes. If for whatever reason your tests hang or break in some way and we're unable to detect it, the device will cease execution after 60 minutes automatically. I should add that it will cease execution after 60 minutes regardless of whether your tests have hung or not. That's actually the default limit on a session or automated test today. And so we encourage you, if you have tests that take longer than that, one, let us know so that we can consider increasing this timeout. And two, we do offer support for filters in many of the frameworks we support. You can also break your tests down into smaller chunks that can run within that 60-minute timeout. There's a question here about what about apps that, for instance, record video through the camera? Can we mock the recorded video? So with video and camera usage in particular, you can use that hardware today from device farms. So the devices, like I mentioned before, are actual physical pieces of hardware. You can use the camera and can use the other pieces of hardware on that device. However, because due to the way the devices are mounted, you're not going to see much of anything, low light conditions and so on. And that's because the devices are physically isolated from one another and from the rest of the world. So you can use the video. Now, if you wanted to do a test or you're testing an application where video was then processed or manipulated in some way, there are a few ways that you can do this. One of the most common ways is using the extra data feature. So in that last step before we scheduled our test, I mentioned that you can upload a zip file with arbitrary data inside of it. So using this method, you could supply a zip file with a video file that you've already created that you want to run through your application or your test will make use of. So this allows you to mock that capability. You could bring this a step further and actually use the camera on the device, record a video, and then on the fly, rather than process the video that you recorded in the box, use the video that you supplied through extra data. So you approximate a full end-to-end test. However, you're not using the video capture from the actual device. And similarly, you could do the same if your application processes audio with a similar, through the microphone, you could do a similar type of strategy where you can use the microphone on the device. You're not going to, due to the way the devices are mounted, you're not going to hear much of anything, but you could mock the data in the same way using extra data. There's a question here about whether devices are jailbroken or rooted. So the devices in Device Farm are not jailbroken and non-rooted. Then the idea is that the devices approximate as closely as possible to what you will find in the wild. So again, if it's a Samsung Galaxy S6 branded T-Mobile, it will be identical to what you would find, what your end users would be using out in the wild. And again, I apologize that I didn't have time to get through all of the questions in today's session. We'll be following up. And again, I encourage you to go to our forums or contact us through our email that was listed at the end of the session. I want to thank you all for joining us today. It's great to have you, and I hope that you will check out Device Farm and that it can help you in your day-to-day development activities. Thanks a lot.
Awesome. Thanks a lot, Trent, for a great presentation. And I'd like to, again, thank the moderators, Nikhil, Powell, and Andrew for answering your audience's questions. If you guys have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars, feel free to send us an email at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com, and your feedback will help us to improve our webinar programming. Thanks again to our audience for taking the time to join us today, and enjoy the rest of your day.